Okay, in this session we're going to talk about quadratic functions. Alright, and alright, quadratic functions, and they take on the form of ax squared plus bx plus c. You may remember this from intermediate algebra, or maybe even elementary algebra. Okay, where we're talking about trinomials, where you have a variable squared, then a variable to the first exponent, then a term without a variable or constant term. So an example would be, let's say, x squared plus 2x plus 1. Okay, so this would be an example of a quadratic. Alright, and I guess try to refamiliarize yourself with, when you've seen these in the past. In the past, we've taken quadratics and we've factored them. So we said, okay, this is a trinomial, and I know, or I assume that I can get to this trinomial by multiplying two binomials. So you do the reverse of the FOIL and you try to figure out what would give you an x squared, and since the x squared is your first term, you would say what in the first position in the first binomial times what in the first position of the second binomial would get you that x squared, and so that would be an x times an x. And then you look at your last term, which would be a plus 1. So what in the last position of the first binomial times what in the last position of the second binomial would get you that. So you have your first and your first giving you your first term, your last and your last giving you your last term, and then on the outside you'd have a 1x, and when you multiply the inside you get a 1x, and 1x plus 1x would give you your 2x, right? So that's basically working FOIL in reverse, factoring a trinomial. Okay, so hopefully this is somewhat familiar to you. And if you notice, the two binomials we end up with are identical. Okay, so what we really ended up doing was squaring x plus 1 to get the trinomial that we started with. Okay, now let's try to, I guess, affiliate this with some of the work we've done so far this semester. Back in chapter 1 we talked about transformations, okay, and we said that basically f of x squared, let's clean this up a little bit. Okay, alright, so I have a graph. I want to graph this. So f of x equals x squared. We talked about how that would give us the graph of a u, and that our initial or our vertex would be at 0. Okay, alright, so something like this. We're not being exact by no means, but just giving you a sketch shape of what the graph would be like for x squared. Really, it'd be more like this. I guess might as well take the time to be more accurate. It would be a graph that looked more like this. Okay, and that's our f of x equals x squared, right? And at this point right here would be considered the vertex. Alright, and anytime we're talking about a quadratic, which is hinted by the fact that our highest degree is a square, then the vertex of a quadratic is going to always be either a max or a min. Okay, the vertex of a quadratic is always going to be a max or a min, or the vertex of a parabola. Alright, the U shape is what we're talking about, parabola. The graph of a quadratic yields a parabola. Okay, now if the lowest point of the U, which is what we have here, this is the lowest point on our U of our graph of our parabola, if your vertex is the lowest point, then it would be a min. However, let's say your U was going down, and if your U was turned down, then your vertex would now be considered your highest point. Right? Your vertex would now be your highest point, and in this case the vertex would now be a max. Alright, so minimum is when the vertex is the lowest point, and the max is when the vertex is the highest point. So basically, if the U is down, then the vertex is a max. If the U is up, then the vertex is a min. Okay, and again, the U, when we're talking about the U, we're speaking in terms of a parabola. The graph of a quadratic is a parabola. Alright, now as it relates to transformations, we said if we take this x plus 1 that we got over here, so now let's say f of x equals x plus 1 squared, we said that the fact that we're adding this plus 1 to our initial function is going to have a horizontal impact, which is going to result in a horizontal shift to the left. It's going to be a horizontal shift to the left 1 unit. Since it's plus 1, it's going to be a horizontal shift to the left 1 unit. Okay, so now what we had would now shift over and would look like this now. Alright, so all we did was take the graph we had and shift every point over 1. Every point got shifted over 1. 1 to the left. Every point got shifted over 1 to the left, and again, that's because of that plus 1 that was added inside of our initial function of x squared. So instead of x squared, we have x plus 1 squared, and that plus 1 inside of the function causes us to shift left 1. Okay, shift our base graph to the left 1. Alright, so now if we notice, when we made the shift, our vertex now right here, our vertex is at the point of x is a -1 and y is 0. Alright, initially our vertex was x is 0, y is 0. Okay, but because we shifted over 1, now our vertex is a -1 and our x is -1 and our y is 0. So that brings us to what we're going to talk about for a second, which is putting a quadratic function into standard form for graphing a parabola. Alright. Okay, so now this is going to be what we call our standard form. Okay, our standard form for a quadratic function. That's what this is. This is our standard form. Alright, so now basically if we took what we have here, then it would look like this. Okay, that's what it would look like, and then simplify it. If we simplified it, we wouldn't write the 1. Okay, so it'd just be out here. It's understood that a 1 is out here. I just wrote the 1 to show you that there is an A out here, but we really don't write it if it's just 1. X, and the fact that we have a minus and a negative together becomes plus. We bring our 1 down, squared, and you have plus 0. Since there was nothing out here, that's the same as saying plus 0. Okay, now once you have the quadratic in standard form, then what the takeaway is that your vertex for your parabola is represented by h k. Okay, h k. Alright, that gives us our vertex. So now you notice when we did the problem here, we said that plus 1 caused us to shift to the left 1. Alright, but really if we didn't know the transformation and we just focused on knowing the form, the standard form, then we knew because we had a plus 1 right here, right? Because we have a plus 1 right here, that our h is actually a negative 1, because the formula says minus x minus h, and if h is a negative number, then minus a negative, then minus a negative is why you see this plus sign right here. Alright, but we must remember h was really a negative 1. So h is a negative 1, and the fact that there wasn't anything out here initially, if we look back over here, there wasn't anything outside of the parentheses, that's the same as saying plus 0, so our k would be 0. So if you notice, just based on putting this function in the standard form, we got the same vertex that we got by just doing the transformation. Okay, so that's how we get our vertex. Alright, so if, let's say, another example, if we had something that looked like, let's say, g of x equals x plus 6 minus 7. Now, you all would know how to graph this based on transformation. The plus 6 would tell you to shift left 6 units, horizontal 6 units to the left, and the minus 7 outside of the function will tell you to drop down, to go down vertically, vertical shift down 7 units. But a quicker way is just knowing that this 6 is really h, and this 7, well actually this 6 is not really a 6, it's a negative 6, because what you're really looking at is x minus a negative 6. Okay, so in this case your vertex is really negative 6, negative 7. So if you were drawing the parabola for this, then your vertex would be at the point negative 6, negative 7. You'd know exactly where to begin your parabola. Let's say you had a function oops, I forgot to put my square back on this. Make sure that's there. Okay, Alright, it's not a parabola without that square there. Okay, so I have a x, let's say minus 3 plus 5. Alright, so in this case, my vertex, which is HK, would be negative 3 and positive 5. Remember, because the formula says x minus h. So this minus sign is part of the formula for standard form. Right? So the 3, oops, I didn't mean this. Take that off. It's not negative 3. It's a positive 3. This minus sign that's right here, excuse me, this minus sign is part of the formula. Again, the formula says a x minus h squared plus k. The minus sign is part of the formula. So this minus sign we have here is part of the formula. So the h is really just the 3. Okay? So if I was graphing this parabola, the negative out here tells me that my parabola would be going down now, and that my vertex would be at 3, 5. Okay? And again, because the parabola is going down, my vertex is the highest point, so that would be considered a max. And over here, because my parabola was going up, my vertex would be the lowest point, so it'd be considered a min. Alright? So let's look at an example. Let's walk through a clean example. Let's look at f of x. Okay. F of x equals 2x squared plus 8x plus 7. 2x squared plus 8x plus 7. Alright, so now this is the traditional look of a quadratic. This is in quadratic, this function is a quadratic. Again, our x squared, x to the first, x to the 0, which is just a constant. Alright, trinomial, 3-term, quadratic form. Okay? Now, we want to get it in standard form. So we want to get this in the form of f of x equals a x minus h squared plus k. Alright, now the first thing you want to do is, when you look at your function, is check your square term. Okay? When you look at your function, check your square term. Alright? And the reason why is because the square term needs to have a 1 for the coefficient on the square. Alright? You need a 1 to be the coefficient on your x squared term. So whatever your x squared term is, you need a 1 there. Okay, so the fact that this is a 2 now poses a problem. So to get rid of this 2, what we do is we see that we have we look at our 2x squared plus 8x, and I know I want to get this 2 out of the way. I need a 1 there, so I need to factor out a 2. Well, I have an 8 here, so I can factor a 2 from this 2 and this 8, and so now I pull the 2 out. Now I've gotten the 2 off of my x squared. Okay, I've gotten the 2 off of my x squared, and that leaves me plus 4x plus 7. Okay, I factor the 2 out of these first two. 2 goes into 2 one time, so it's like saying 2 times 1x squared would be the 2x squared. 2 times 4x would be 8x. So I pull out a 2, I'm left with 1x squared plus 4x. I still have the plus 7 out there. Now we're going to use a process called completing the square. Alright, because again, we're trying to get it in this form, so we have to complete the square. is what it's called. Complete the square. Alright, and what that calls for us to do is to take our x term, alright, not the x squared, but our x term, okay, which is considered our b. Alright, take our b term, divide it by 2, then square it. Take our b term, divide it by 2, then square it. Okay, and in this case, our b term, or our b, is the 4. Okay, our b is the 4. So if we divide it by 2, okay, if we divide 4 by 2, you get a 2, right? And then so we said we have to divide it by 2, then square it. So we took our 4, divided it by 2, and that gave us a 2. And then we said then square it. 2 squared gives you a 4. Okay? So now I keep my 4x, alright? I keep my 4x that I had, but this 4 that I got right here is going to be added on. Okay? So this 4 that I just got by completing the square, because basically what I've done is taken this x squared and was plus 4x. This is a binomial now. I've isolated this when I did my factoring of the 2. I've turned this into a binomial. And because I want a trinomial, alright, to complete the square, I divide my b, my 4, by 2, then square it to give me a 4. And now that gives me a trinomial again. Okay? That gives me a trinomial again. Alright? But because I add 4, I can't just add 4 out of thin air, so I subtract 4 to balance it. Plus 4 minus 4. This 4 and that 4, okay, plus 4 minus 4 is like saying I added 0 because they cancel each other. So I really haven't done anything to change the problem, but doing it this way allows me to get the problem in the form that I want. And again, because I'm multiplying this 4 by the 2 that I factored out, because this 2 is here for this 4, I also have to put the 2, and I don't necessarily want to make it look like that. Let's do this. Let's bring this down. Alright, and again, because I've added 4 out here, I have to subtract 4. Okay? I have to subtract 4. And I have to multiply this minus 4 times 2. Alright? And I can't forget the plus 7 that I had sitting out here as well. Okay? So again, this 4 comes from completing the square, taking the 4, dividing it by 2, then squaring it. That's where this 4 comes from. This minus 4 is just my way of balancing plus 4, because I can't just add 4 out of thin air. The initial problem didn't have a plus 4 in it, didn't have this in it, so I can't just do it out of thin air. But if I need to add it so I can get it in the proper form, then I can just balance it out by subtracting it outside. Okay? So plus 4 minus 4 is just like saying 0 again. Okay? But now, because this 4 is inside of parentheses and it's being indicated that it will be multiplied by 2, then it's only fair that this minus 4 has to also be multiplied by that 2. And again, I just brought my 7 down. So keep my 2. I have a trinomial, and we've talked about factoring trinomials. Alright, my negative 4 times 2 is a negative 8. Bring down my plus 7. Reverse FOIL, x plus 2 plus 2. So you notice first times first gives you the first, last times last gives you the last. Outside gives me a 2x, inside gives me a 2x, 2x, and 2x gives me 4x. Okay, so my binomial times binomial is correct. And notice that the two binomials are the exact same. So what I have is x plus 2 squared. Negative 8 plus 7 is a negative 1. Now I have my standard form. There's my a, x, my h, which again, because the formula says it's supposed to be a minus sign, what you're really looking at is minus a negative. So this is really a negative 2. Okay, not a 2, but a negative 2. And then there's my k. So if I needed to know the vertex for this one, then it'd simply be h, k. And again, my h is a negative 2, and my k is a negative 1. And there's my vertex. Alright, now, a couple other things with parabolas. Alright, because parabolas present a U-shaped graph, then we know that that graph is symmetric. Okay, it's symmetric. So based on the form we have, we can determine, and based on what we find to be the vertex, we can determine what is called the axis of symmetry. Okay, and the axis of symmetry is simply whatever your h is in your vertex. Okay, so you would draw a vertical line. Oops, I'll write that. A vertical line through your h. Okay, whatever your h is. So we said our vertex, okay, negative 2, negative 1. So if we had our graph, alright, whatever, okay, we have our line. So we say our vertex, negative 2, negative 1, right there. Okay, and our graph is going to be U-shaped. We already discussed that. Now this is just a rough sketch, not the scale. Okay, now what we're saying is, because negative 2, negative 1 is our vertex, then our axis of symmetry would be x equals the line x equals negative 2. X equals negative 2. So x equals negative 1, x equals negative 2, the vertical line of x equals negative 2. So this line would be considered our axis of symmetry. Alright, it's the line that the U would pivot around, the parabola would reflect around. Okay, that's our axis. Alright, got it? Let's look at another example. Let's try some more problems. So let's go with f of x equals negative x squared plus 6x minus 8. Okay, and we want to find the vertex, and now we also want to find the intercepts. Okay, we want to find the vertex and the intercepts. Well, we're going to put it in our standard form. Okay, so we notice again we always want a 1, and in fact we want a positive 1 on our x squared. In the last problem we had a 2 here, and so we factored out a 2. This time we have a negative 1 on our x squared. Okay, so we want to get rid of this negative, and remember we're just going to focus on the x squared and the x term. Okay, the x squared and the x term. So I'm going to focus on that, factor out a negative. So now I've gotten rid of the negative on my x squared, but if I factor out a negative from my 6x, now it becomes minus 6x. Okay, think about it. Negative times x squared would give you negative x squared. Negative times a negative 6x would give you a positive 6x. Okay, so now we're looking like this. We factored out, we've got our x squared with a positive 1 for a coefficient now. Okay, so now we got to complete the square. So remember, we take our b, which is the term that's which is the number that's attached to our x, okay, divided by 2. So 6 divided by 2 equals 3. Okay, then we take that number and square it. That gives us a 9. Alright, so we're going to complete the square by adding a 9 in. So we have our negative x squared minus 6x plus 9. Alright, now because we had a plus 9 to offset it, we should also have a negative 9. Alright, plus 9 minus 9, they cancel. That's like saying 0. Remember, we can't just add 9 out of nowhere because 9 wasn't in the original problem. But we need this 9 to help us get it into form. So if we add 9, we can simply take 9 to keep the problem balanced. Okay, but because this plus 9 is being indicated as being multiplied by a negative 1, then I want to do the same to the negative 9, and the minus 8 should still be in the picture because we haven't done anything to it yet. Alright, so now we have negative, then you have x squared minus 6x plus 9, and you have a plus 9 because a negative 9 times a negative 1 is a positive 9, plus 9 minus 8. That's negative. Do your reverse FOIL. 9 minus 8 is a positive 1. X minus 3 minus 3. First and first gives me first. X and x is x squared. Last and last. Negative 3 times a negative 3 is a positive 9. Outside, negative 3x. Inside, negative 3x. Negative 3x minus 3x is a negative 6x. So everything checks out. Once again, my binomials are identical. So now I can rewrite this like that. It's 2x minus 3, so x minus 3 squared plus 1. There you go. Okay. So in this event, now my a is a negative 1. Okay. This is my a. Whatever's pulled out. In the last problem, a was a 2. Okay. My h is a 3, because remember the formula is x minus h. So x minus h, so h is just a 3. The minus sign is part of the formula. Part of the formula. So it's x minus h, so h is 3. My k is 1. Here, plus k, h plus k. There's my k. K is the 1. So my vertex is 3, 1. Alright. Now, the fact that my A is a negative, okay? If your A is a negative, that tells you that when you graph your parabola, it's going to go down, okay? The fact that A is a negative number. The fact that A is a negative number tells me if I were to graph this, my parabola would be U down, let's say. So my vertex, my 3, 1, would be considered a max. Alright, 3, 1, that point would be 3, 1, and it'd be a max. Okay? So, and our axis of symmetry is, again, whatever H is. So our axis of symmetry would be the line of X equals 3. Okay? Now, a couple other things we can find. Alright? We can find our x-intercepts. Okay, we'll find our x-intercepts. So we go back to our initial problem. So our initial problem was f of x equals negative x squared plus 6x minus 8, and to find our x-intercepts we make y0. Alright, to find your x-intercepts you have to make y0. Okay, so we've talked about f of x is the same as just saying y. F of x is just another way of saying y, so we make y0. Alright, and I'm going to show you another way to come up with these x. We've traditionally been looking at doing reverse FOIL to get two binomials, but I'm going to show you another way called the quadratic formula, and it's x equals negative b plus or minus the square root of b squared minus 4ab no, excuse me, 4ac. It's a mistake. That should be a c. 4ac all over 2 times a. Okay, where based on our initial problem, a is a negative 1, b is 6, and c is negative 8. Alright, so a is a negative 1, a, b is a positive 6, and c is a negative 8. There they go. So negative b, 6 is b, so negative 6 plus or minus square root b squared, 6 squared is 36, minus 4 times a negative 1, a is a negative 1, c is a negative 8, okay, all over 2 times a negative 1, so negative 6 plus or minus square root 36, and now we have, what is this, negative 4 times a negative 1 is a positive 4, positive 4 times a negative 8 is a negative 32, divided by negative 2. Okay, so you end up with negative 6 plus or minus square root of 4 over a negative 2, which gives you negative 6 plus 2 over negative 2, and negative 6 minus 2 over negative 2. The negative 6 comes from here. Now in this problem we say plus 2, because the square root of 4 is 2, and over our negative 2. In this problem we say minus the 2. Negative 6 minus 2, because the square root of 4 again is 2, over the negative 2. Negative 6 plus 2 is a negative 4. Negative 4 divided by negative 2 is 2. Negative 6 minus 2 is a negative 8. Negative 8 divided by negative 2 is a 4. Okay, so this is telling me that I have x-intercepts at 2, 0, and at 4, 0. Okay, now y-intercept. Y-intercept is typically easier. You find it by making x 0, solve for y. And again, our initial problem was this right here. And if you make x 0, x is 0, so that would disappear because x is 0. Negative 0 squared is just 0. If x is 0, 6 times 0 would just disappear. So you just be left with f of x equals negative 8 if x is 0. And remember, y, we're looking for the y-intercept. Y is the same as saying f of x. So y would equal negative 8. So for a y-intercept, you'd have 0, negative 8. Okay. So if you were graphing this, and it'd be hard to do right now, let's say I'll write all this over here. So we have our a is negative 1, h is 3, k is 1, axis x equals 3, vertex 3, 1 is a down, and our vertex is a max. We can say our x-intercepts, based on what we just found, are 2, 0, and 4, 0, and our y-intercept is 0, negative 8. So what we can do with this information, let's just erase all of this here. Okay. Give ourselves some room. Alright. Bear with me for a moment here. Okay. So let's graph. Let's say we're here. And we'll make the other line here. Okay, so x-axis and y-axis. Alright, now our vertex is 3, 1. Okay, our vertex is 3, 1. So we know our parabola is going to extend out from our vertex. So we go 1, 2, 3, up 1. So there's our vertex, 3, 1. Now we know that this is a parabola that's going to be going down from here because our a is negative. Our a is negative. So we know that our parabola, when we graph it, is going to be going down. Okay, and that our vertex represents a max, a maximum, and that when we draw our parabola, it's going to cross the x-axis at 2, 0 and at 4, 0. So it's going to cross the x-axis at 2, 0 and at 4, 0. Okay, 2, 0, 4, 0. Alright, and then the other thing we know is it's going to cross the y-axis at 0, negative 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So it's going to cross the y-axis right here at negative 8. So when I draw my U, I know it's going to look something like that. Nice, ugly graph. Here, let me try to clean it up just a little bit more, a little bit better. Alright, we know our axis is at x is 3 because the h in our vertex is 3. The h in our vertex is 3. So our axis is that line right there. That's our axis. Okay. So 2, 0, 4, 0 would be our x-intercepts, because that's where the parabola crossed the x-axis. And 0, negative 8 is my y-intercept, because that's where the graph crossed the y-axis. Now, let's see here. Quick question. If you had your graph, and let's say we were graphing something, and it was going to be a parabola going up. Okay, parabola going up, and the vertex is above the x-axis. Okay, anytime you have a situation like that where you have a parabola that's going to be going up, so in other words, your A would be a positive 1. Okay, your A would be well, not necessarily a positive 1, but your A would be positive. Okay, if your A is positive, and for your vertex, which is HK, right? If your A is positive and your vertex, which is HK, and if your K is greater than or equal to 0, okay? If A is positive and K is greater than or equal to 0, then you will have no x-intercepts. Alright, so that's a trick that when people ask you to give the intercepts, and they'll give you a problem that will work out like this, and you're stuck trying to find the x-intercepts. But because A is positive and your vertex and your K of your vertex is greater than or equal to 0, you will never have an x-intercept. And if you look, you'll see why. If this is my vertex and my parabola is going up, these will never cross the x-axis. They're going up and away from the x-axis. Okay, that's why you will not have an x-intercept. You will always have a y-intercept, but you won't have an x-intercept. Now, on the other hand, if A is negative, okay, if A is negative and my K, remember, vertex is HK, and if my K, alright, my K is less than or equal to 0. Alright, if A is negative, negative 1 or whatever, negative 6, whatever, and K is less than or equal to 0, once again, there won't be an x-intercept, because that would be like saying if you had a vertex right here, and the fact that a is negative says that your that your parabola is going to go down, right? And because your vertex is below the x-axis, your parabola is going away from it, so it will never cross this axis. It will never cross that line. Okay, so just something to keep in mind. Alright, last problem, last example. Okay, now let's say we're given that we have a vertex of 1, 2. Okay. Alright. So we want to write the standard form of the equation of a parabola whose vertex is 1, 2, and the parabola is going to pass through. Okay. And the parabola is going to pass through the point 3, -6. Okay, we want standard form of the parabola that has a vertex of 1, 2, and that would pass through the point 3, -6. Okay, remember that our vertex is the same as saying h, k, and any point is the same as saying x and y, right? And that the form we're looking for is f of x equals a times x minus h squared plus k. That's our form we're looking for. That's what we want. Well, we have a y, and remember f of x is the same as saying y. We don't have an a, so a is still unknown. We have an x. X is just 3. Okay. We have a k. Not a k, a h, excuse me. H is 1. And we have a k. Our k is 2. Alright, so we see that we were provided everything except for a in this problem. Alright, so we have our -6 equals a. 3 minus 1, 3 minus 1, which is just 2 squared plus 2. Alright, we're going to solve for a, see what a needs to be. Now 2 squared is 4, so that's like saying 4a plus 2. Subtract 2 from both sides. -8 equals 4a. Divide by 4. Divide by 4. A equals -2. So now that we have a, we can write our equation in standard form. So our equation is going to be f of x equals a x minus our h, and our h is 1. We said our h was 1 from our vertex, right? Our h is 1 squared plus our k, which we said is 2. Okay, so that would be your final answer, or put an equation in the proper form, which would be f of x equals a -2 x minus 1 squared plus 2. So that would be putting it in its proper form. Okay. Alright, I know there's a lot to digest at once. Take your time, go through these, and as always, if you have questions, feel free to email me, text me, or just wait till we meet in class and we can discuss it then. We will now conclude the session.